Welcome to note set number 5. Alright, so today we're going to learn about parallel and perpendicular lines. So you might have heard the words before, but two parallel lines are two lines that never cross. Never ever. And perpendicular lines are two lines that cross at a perfect 90-degree angle. So those are the definitions. I'll explain them. I'll show you pictures. We'll talk about it more. All right. I'm going to scroll. We're going to start with parallel lines. So if you look, these two lines are parallel because they never cross. Like if they were to continue forever and ever, they're never going to cross. So we're going to figure out the equation of both of these lines by using the graph. So I'm going to call one of them line 1. Let's make it this bottom one. Number 1, and this one's going to be number 2. So remember for the equation, it's y equals, first we need the slope. So I'm going to pick this point because it crosses perfectly at an intersection. And this one is a decimal. I'd have to guess. This one's a perfect cross, right? So to go from, and you always go left to right, so this is the first dot. To go from here to here, I have to go down 1, 2, 3. So I'm going down 3, and then divided by how far over, 1, 2, to get to that dot. And then x, and then you add your y-intercept, and it's crossing your starting amount, it's crossing right here at 1. So then you add 1. That's the equation of this line. For number 2, I'm going to do the same thing. So let's see, let's find some perfect crosses. No. Here's a perfect cross right here. No. Here's another perfect cross. Cool. We have 2 perfect crosses. So it always starts with y equals, and then to go, again, left to right, so starting with this one, I have to go down 1, 2, 3, which makes it a negative 3, over, and I go right 1, 2, so that's my slope, x, plus, and then my y-intercept, this one started up here at 7. So plus my b is 7. So if you look at both of these, their starting amount's different. This one started at 1. This one starts at 7. However, they're growing. Their slope is the exact same. For both of them, you're going down 3 every 2 times. So of course they'll never cross. They're taking the same journey. Each time they're changing by the same amount. And since they started at different places, but they're changing by the same amount, they'll never cross. Which means if you scroll or look at the bottom of your page, it goes parallel lines. And what you need to write, but I can't find my eraser. Oh, found it. Is that because of the equations that we saw, we see that parallel lines always have the same slope. Parallel lines are always growing in the same way. They have the same slope. All right, let's talk about perpendicular lines. All right, so remember I told you 2 perpendicular lines cross perfectly at 90-degree angles. So if you look at these 2 lines, it's like I could put a little square in there, in all of them, because it has like a perfect cross. So like the not perfect cross, those aren't perfect. I can't put a fit a perfect square in there. However, I could if it was like that, because now I can get a perfect square and a cross. Perpendicular lines cross at perfect 90-degree angles. And a good 90-degree angles is like you could put a little square in it. Okay? So to figure out the pattern for perpendicular lines, we're also going to find the equation of both. So yours, I gave lots of room. I can't see both at the same time on this, so I'm going to put equation 1 here, and then I'm going to write equation 2 over here. Feel free to write yours where it has it, like just underneath. All right, so why don't we make this one number 1 and this one number 2. So let's try to find a perfect cross. It looks like there's one right here, like the very first one, and then the next one doesn't happen till here. So to figure out my slope, y equals, to go from this dot to that dot, I'm going down 1, over 1, 2, 3, 4, 5. And then x, and then plus, its b is like a decimal, like where this red line's crossing that y-intercept, if you look. And so I'm going to guess maybe, I don't know, I think it's about 0.2. If you ever have to guess, it's okay. I won't count you wrong if you put 0.3 or 0.1. As long as you realize it's beneath half, it's beneath 0.5. All right, and then for line 2, let's find perfect crosses. So there's this one right here. And it looks like the next one is right here. So to go from this point to this point, I'm going up 1, 2, 3, 4, 5. So it's y equals, I went up 5 over 1. And then there's x. And then its b, it crossed the y-intercept down here at -5. So -5. So look at the two slopes. This one's 5 over 1. This one's -1 over 5. They're almost the exact same, except they're flipped over. And it's opposite. One of them's negative, one of them's positive. So if you scroll to where it says perpendicular lines are, let's see, perpendicular lines are, their slopes have slopes with, I'm going to start with the word opposite, because I mean opposite sign. If one of them's positive, the other one's negative. And then the next word is reciprocal. Reciprocal. Which I'm assuming a lot of people don't know, because it's a weird word. But all the word reciprocal means, and I'm writing it right here, is to flip the fraction. So these two numbers are reciprocals of each other because they're just flipped over. So when they're perpendicular lines, always, always, their slopes have opposite reciprocals. So here's why the definitions of these matter and why it matters what we do with these slopes. Because I can give you an example if you flip the page. I can give you an example where I say create an equation of a line, so a brand new line that happens to be parallel to this line, right? And I'm going to force you to go through this point. So here's the thing. If this line, if I graph it, and you don't have to graph it, but if I were to graph it, if it looks something like, oh, let's say like that, right? I need any other line that's parallel. So like this line's parallel, this line's parallel, this line's parallel, this line's parallel. There's tons of parallel lines. But I also want the one that goes to this specific point. So because of this point, I'm forcing you to find one line that happens to be parallel to this one, but also goes to that point. Well, here's how you do it. Parallel lines have the same slope. So because of this, because of parallel, I know that the slope's going to be the same. Same slope. Meaning my new line, y equals, my slope's also going to be 1/3. So all these words do is tell you the slope of your new line. So if it says parallel to, it means it's going to have the same slope. And then you're going to plug in this point. Remember, it's x and then y. So if I plug in the point, my y was -4, 1/3 x was 9, plus b. If you type that in a calculator, you get 3, because 1 times 9 is 9, but then divide it by 3 is 3, plus b, to solve, I minus the 3. To find out -4 minus 3 is -7 equals b. So my answer is y equals 1/3 x minus 7. And this is the equation of a line that is parallel to this one because they have the same slope. But because of this b, I make sure it goes through that point. I followed the instructions. So then, if instead of saying parallel, I say perpendicular, like in this one, it says create the equation of a line that's perpendicular. What this means is the slope is opposite reciprocal. Which means this is 1/3, but when I flip it over, it becomes 3/1. This one's positive, this one needs to become negative. So my slope is y equals -3/1, x plus b. This is the point we want to force it to go through. So -2 is my x, +2 is my y. So y is +2, -3/1, parentheses -2, because that's my x, plus b. When I multiply -3 times -2, I get +6, and then divide by 1 is still just +6. It's b. To solve for that b, I need a minus the 6 from both sides. 2 minus 6 is -4, so that's my b. So then the equation of a line that is perpendicular to this is y equals -3/1x, that makes it perpendicular, and then with the b of -4, it forced it to go through the point -2, 2. And that is the equation of that line. So sometimes in math, we can have slopes of 0. Here's what it would look like. Let's say it's y equals 0x plus 2. Means I start at 2, then after one time I get nothing, so I still have 2. And after the next time I get nothing, so I still have 2. And after the next time I get nothing, so I still have 2. And it ends up being a flat line right here, where y is 2. So here's the thing about 0x, you don't even have to write 0x. This is just y equals 2. So this is not actually a linear equation, even though it makes a straight line, because it's a flat line, it's called a constant. Because it's constant, it's constantly 2. Y is constantly 2, the answer is constantly 2, right? So if that has a slope of 0, and I say create a line that's perpendicular to a slope of 0, well remember, you can take any number, divide it by 1, and perpendicular means opposite, so it becomes negative. Reciprocal, 1/0. And if you plug that into a calculator, it's going to say, error, you can't do this because you're not allowed to divide by 0. It's against the rules. Like you can't take $1 and give it to no people and have an answer. Like it doesn't even make sense. So you cannot divide by 0, so there is no slope. And it's like, well, how does that happen? Here's how it happens. Imagine taking this flat line and turning it 90 degrees so it has a perfect cross. Like here's a constant, a flat constant. And if I try to make a perpendicular line and turn it and get a perfect cross, this is my new line. This up and down line, it's a straight up and down line. That's not a function. You're not allowed to have a line going straight up and down as an equation, because you can't have something on top of itself. If you remember the what is a function lesson, that you can't have things on top of itself. So there's no way this up and down line can even be an equation or even have an equation to it. Which just means you can't take a line with a slope of 0 and make a perpendicular